Okay, I think it's 4:30 and we are good to start. Pranshu, am I audible?
Yeah, you are audible, sir.
Okay, great.
I cannot switch to my screen or anything. मेरा presentation.
Okay, okay. So probably Nishant can give me the inputs and feedbacks. So good afternoon, friends, and thank you for being here today. Today, I think we are going to be discussing about high vacuum pump packages, which are commonly used in used oil or waste oil re-refining, and how we go about designing these systems, and what are the advantages that you can get out of these systems. So I would like to go to the agenda, the topics that we are going to be covering today. So we'll start with a brief introduction about Everest Vacuum. We'll cover the geographies where we have our presence, the certifications that are available with us, the awards and recognitions that we have received, and the product range. And then after that, we will be moving on to the actual topic. So not taking too much of time in covering the initial part, we'll be moving on to the oil cyst vacuum systems. How we design these systems and what are the advantages that you can expect out of these systems. The commonly asked FAQs that are there or the objections that are raised most of the times by our customers, and what are the answers. We will also be covering the best practices of do's and don'ts. We'll be sharing a cost benefit analysis document as well with all of you. And after that, we will be taking up any questions that are there by our esteemed customers who are present today in this webinar. So moving on, what EverestVacuum is, because this is an international webinar and we have customers from all over the globe attending it. So we first wanted to introduce our company. So EverestVacuum is a manufacturer and exporter of dry screw vacuum pumps, roots vacuum pumps, industrial vacuum systems, and engineered vacuum packages for all chemical, process, and pharma industry. Everest Group started its operation by manufacturing twin-lobe roots design blowers way back in 1980 and soon became popular for its high volumetric efficiency and consistent product quality. Today, Everest Group has QMS quality management system, which is ISO 9001, 14001, and 45001 certified. We have facilities in-house for design, production, manufacturing, quality control, inspection, and after-sales services. EverestVacuum, which is the recent baby of Everest Group, was established in the year 2007 and has done a consolidated revenue of more than 350 crores Indian rupees and helped customers save more than 5,000 crores. EverestVacuum has catered to more than 1,450 customers across 29 countries, with a total percentage of repeat customers of more than 48%. Now, this I am talking about capital equipment industry. We have much better than benchmark of repeat customers coming back to us. In association of business with EverestVacuum, the clients have registered a growth of 136% in their revenues, with savings of more than 3.5 crore hours, productive hours in their production. The average delivery time for our customer ranges between 20 to 30 days, which is almost half as compared to industry benchmark for similar products. So what we truly believe in, or what a percentage that we monitor is, we call it in-house, popularly we call it as OTIF, on time in full delivery. Our delivery periods as compared to benchmark industry standards of similar products are almost half. Our tagline here says we don't just offer blowers and boosters, we offer complete solutions. Now, EverestVacuum, when we started, was established to provide the best engineering solutions to our customers. Application engineering based company with majority staff having a technical background. So that's, friends, a little brief about EverestVacuum. Coming to the next slide, our customer base all around in various continents. We have just highlighted which all countries we are present in. As I told you, we are present in more than 29 countries. We have our customer base all around the globe. Coming to the next slide, the strengths of EverestVacuum. So EverestVacuum has 7 product lines, and in total we have 78 product SKUs and 2,581 unique items. We have manufactured and sold more than 8,758 machines in the last 14 years. We are a strong process-driven company, having more than 20 flow management systems, more than 33 process checklists, more than 2 production management systems, one for the pump line, that is the pump and the mechanical vacuum booster, and other one is for the systems, the vacuum pumping systems. 3 inventory management systems, one for the pumps and boosters, the second one for the systems, and third one for the spare inventory management, having a total of 1,067 checkpoints to ensure smooth and efficient delivery of quality products to our customers. If I talk about our product range includes mechanical vacuum boosters, dry screw vacuum pumps, industrial supervac vacuum systems, mechanical vapor recompressors, low temperature thermal evaporation technology LTTE, super sucker, and rotary vane vacuum pumps and systems. So the various product lines I have shown over here. Now, if I talk about production capacity, we have the capability to manufacture 600 vacuum systems, which includes both standard and engineered. Standard are off-the-catalog vacuum systems, and engineered vacuum systems are custom-built vacuum systems, which are built specifically for customer based on his requirement. Apart from this, we have capability to manufacture 800 roots vacuum pump and about 350 dry screw vacuum pumps. As I already told you about our offerings, I'll be showing in the slides now our various offerings that are available there. Apart from this, I will also like to focus or emphasize on our promise or our commitment to our customers. So what our promise to our customers is, we promise to offer clean, reliable, and sustainable vacuum, improved product yield for the customer, deeper and consistent vacuum, cost and space saving by the right product sizing, reduced operational cost is what we tell our customers that they should be expecting when they buy products from us. Coming to certifications now, as I told you before, we are a ISO certified 9001, 14001, and 45001 company. Apart from these, we have CE certification both for our mechanical vacuum booster as well as our dry screw vacuum pump, and ATEX certification as well for mechanical vacuum booster and dry screw vacuum pump. Coming to patents now, EverestVacuum has been granted several patents for its excellence in innovation in the field of vacuum pump and sealing mechanism design. Along with this, we have many design protections also to safeguard and protect the innovation in our design. So the first two that you see, the blue ones, are the patents, utility patents for our dry screw vacuum pumps. One is for the screw profile and the other one is for the sealing mechanism. These are both innovative designs which enjoy novelty. Nobody else in the world is using this concept to manufacture these designs. How does this help us is our pumps, because of this patented screw profile, are almost 30% more power efficient as compared to conventional dry screw vacuum pumps. And similarly, our roots boosters have more than 20% higher volumetric efficiency. If you compare it with other Indian manufacturers, uh, for roots, which helps us in two ways. Our power consumption is low and our ultimate vacuum is higher. The green certificates are the certificates of design protection. We have protected our design so that nobody copies it. Moving on. So this was a brief introduction about what EverestVacuum is all about. But I am sure you all know us and know us well enough. So without wasting any more time, I would like to now come to the topic at hand, which is the oil cyst, the sales presentation for Everest oil cyst vacuum system. So as you can see on the left hand of the screen is the photograph of a typical oil cyst vacuum system. And at the bottom, if you see, are the 6 different models of oil cyst that Everest manufactures. Now, every model, whatever is the number written in front of it, like oil cyst 6300 typically means it is a 6300 meter cube per hour machine. So the smallest machine that we manufacture is from 3000 and the largest machine that we manufacture is 30,400 meter cube per hour, which is the skid 5. So to start with, I would like to start with the basics of what is used oil. So used oil, by definition, if I want to define it in a simple way, the simplest definition of used oil is any oil that is not virgin is called as used oil. Oil that is recycled is used oil. Now, oil, like water, it can never be destroyed. It can only be contaminated. So, by distillation, we can recover the base oil back and we can reuse that oil. That is the basic principle of used oil distillation. The sources of used oil, generation of used oil, we have shown over here. It can be from automobile, it can be from aircraft industry, it can be from process industry, it can be from trains. There can be multiple sources. But in principle, oil, base oil will never lose its property. It can only get contaminated. How it will get contaminated, I will be covering in the next slide. So this is the cycle, how base oil is prepared. Just go back to the last slide, please. How base oil is prepared. From base oil, how lubricant oil can be prepared. It is used in the process. Used oil is then collected back, sent back to the refinery, and it is further again distilled back to convert it back into base oil. Next slide. So now, like I told you, oil properties, oil will never lose its properties. But then what is it that contaminates the oil? So here we have given a typical breakup of what can be the contaminants which will contaminate the oil. So if I talk about oil alone, the oil part of it, 70 to 75% of typical waste oil that we collect is base oil or lube oil. 5 to 10% is addition of fuel that is there in it, majorly diesel or kerosene. Some amount of water is available, which is about 10 to 20%. Then some amount of additives that are added to the oil, which are spent additives, are also available in the range of 5 to 10%. Some amount of sludge, that is the base at the bottom, which is the residue, carbon residue, which is caused by hydrocarbon cracking, is at the base that gets collected. So this is the basic constitution of used oil. Now coming to distillation, what are the various types of vacuum distillations that are commonly used, commonly practiced? So there are two main types of vacuum distillations. The first one is direct distillation, which is also popularly in industry called as batch process. Here, direct heating is done by either fuel or thermic, and it causes evaporation within the vessel. The other one are continuous processes, which are now becoming very popular. First one being the white film distillation, and second one being the thin film distillation. So every distillation for vacuum that is done is being done under vacuum, or for oil that is being done under vacuum. Now coming to the next question that people mostly have, why use an oil cyst? The technology behind oil cyst. So oil cyst, as the word suggests, is a registered word that we created for this vacuum package. It consists of a liquid ring vacuum pump, an air liquid separator, a filter unit condenser, heat exchanger, recirculation pump, and all of this is mounted on one common frame. The system typically is a three-stage system. Now it can either be a three-stage, or in some cases where the capacities are higher, it can also be a four-stage system, with the backstage being a liquid ring vacuum pump and the stages on the top. So if you have two more stages, both will be roots design backed by a liquid ring vacuum pump. During the operation, the vacuum pump ejects the gases sucked from the process through the discharge port that is connected to the air liquid separator. Now the blue vessel that you see here, that is the air liquid separator. The gases coming out of the air liquid separator is dried with only saturated vapor, which is further passed into the boiler, where any residue vapor gets burnt and its energy gets utilized. Now, we typically call this type of a system as a semi-dry system. The reason for us to call it as a semi-dry system is because the complete circuit of sealing fluid is 100% recirculation and reuse, thus saving the customer substantial cost of fresh oil or water. The other advantage that the customer gets by using this system is that the system is fully equipped with a cyclone separator at the suction. At the suction is the opposite side. Pranshu, can you just point towards the suction cyclone? So that suction, that cyclone is there. Apart from the cyclone, there is an intermediate condenser, and after the condenser, then there is a filter trap unit. Along with this, at the discharge, there is an air liquid separator, which is a very efficient design to ensure that the vapor that is coming out after the liquid ring vacuum pump does not carry away any oil droplets with it. There will be some amount of oil that will get carried forward, but that will be saturated oil. That will not be droplets of oil which will get carried forward. So that is where this ALS becomes a very important accessory to use in this type of an equipment. The system has very low pollution footprint and no additional effluent generation. Because of all these features, the system is termed as a semi-dry system. So that is the technology that is there. Everything over the experience of so many years, we amalgamated everything, brought it on a compact skid, and today we have more than 200 such machines running all around the world. A typical PNID of how the setup looks like. So at the suction, there is the vessel, the distillation vessel, in which the raw material or the feed is fed in. Now here we have shown a direct distillation vessel. Heating is given to the vessel for distillation to be carried out. After that, there are two condensers, the primary and the secondary condenser, that are installed, where all the vapor that is being evaporated from the process gets condensed and collected in the receiver. Because this is a high boiler, vacuum is connected into the receiver. As we are very well aware that there will be no further carryover of vapor by connection into the receiver into the vacuum pumps. Typically, we promote and we tell customers to always collect condenser to connect vacuum in the condenser and maintain condenser as the lowest vacuum point in the whole circuit. But in such cases, we don't mind connecting it with the receiver, the holding tank, which is before the receiver, just for the fact that here, whatever we are dealing with are all high boilers. And then you have the typical system on the other side, which I have already shown in the previous photograph as well. A typical three-stage system with two root vacuum pumps or mechanical vacuum boosters, intermediate condenser, filter unit, and then your liquid ring vacuum pump or oil ring vacuum pump with a recirculation system and a ASL. Completely skid mounted with an electrical control panel which has all the philosophy built into it. Coming to the process now, the process of lube oil re-refining. So this is the most common and popular process for re-refining or distillation under vacuum. In general, this process is covered in batch. Earlier, most of the installations were batch installations, but now with efficiencies coming in WFE, falling film, we are seeing people and the quantities becoming larger of oil getting treated. We are seeing people making this switch. So if I want to tell you the whole process, I will categorize the whole process into 4 stages. Stage 1 is the stage of dehydration. At stage 1, we are removing water and other low boilers that are present in the system. This stage removes all impurities which are low boilers, and the temperature rise is not very high during this stage. The second stage that is there is the stage of diesel cut. After dehydration and fuel that is mixed into the used oil such as diesel or kerosene starts evaporating, this typically evaporates at 150 to 180 degrees and can go up to about 200 to 110 degrees. But at that range, all diesel or fuel that was mixed into the oil, into the used oil, gets evaporated and comes out of the system. Then you have the stage 3, which is called as the light loop cut. Now, loop cut is the base oil. This can be categorized into two categories, light as well as heavy. So first, the light loop cut oil will start coming out, which will peak out at around 250 degrees Celsius. After this will be stage 4. This is also called as the final cut and is the most important cut, as maximum flow happens during this cut. On the top cuts, the flow is very minimalistic because 70% is being constituted by this particular cut. So this cut will typically start at around 265 degrees and will range up to about 280 degrees. And in some cases, like here, if you see on the right hand side, we have shown two lines. One is the light blue line and one is the dark blackish line. If you see here, what we've done is in between 260 to about 280, we received maximum flow of oil that came out of the system. Still, we took up the temperature to about 320 degrees to see what happens. We observed that after taking the temperature, after 280 degrees till about 320 degrees, even though we increased the temperature, and because the vacuum level was so high, we observed that we had already extracted maximum heavy lube from the system, and beyond 280 degrees to 320 degrees, finally we saw that there was no flow coming out. We had already recovered maximum material that was to be recovered till about anywhere between 280 to 300 degrees. From 300 to 320, flow level was negligible. Bottom that was left behind was all the impurities, which is also called as waste, that was drained out separately and sold into the market, because that also has some residual value. Next slide, please. The results of this were the used oil specification that we received. That was the blackish oil, was the input with the parameters on the left hand side. And output base oil specification was the distilled oil, the goldenish yellow oil, which was not refined. There was no solvent treatment that happened to this oil. It was goldenish pale, golden, light golden in color, with these specifications. Now, coming to a slide that is very important in this scenario is the cost benefit analysis. So we did our study to understand that what is the value that Everest brings on the table for our customers. How are we different, and how can we do that additional bit for our customer that we can save extra money for them, extra cost for them. So when we were doing this experiment at one of our customer site, we categorized the savings. He was earlier using a conventional technology, which was also roots with reciprocating piston pump. But we shifted it from that technology to our oil system. So he was not using Everest roots, he was using roots from some other company, and he was using a piston, reciprocating piston pump also from some other company. When we supplied him this oil cyst vacuum system, we observed that he was saving money in 6 different categories. So I will be covering all of those 6 different categories over here. The first saving that the customer had was by increasing the yield. We were able to increase the yield of our customer by 2%. This means all that yield, all that extra material, that's heavy lube, was being left in the bottom in the product and being sold by the customer in as bottom outside. So we increased his yield by about 2%. Now, just for ease, I will take example of skid 3 over here. Skid 3 is a skid which has the capability to run 22,000 liters per batch. Saving 1, increasing 2% yield, saved the customer approximately 79 lakh rupees in INR. Or if I talk in US dollar, then about 100,000 US dollars per annum. These are all savings that have been annualized. Only by increasing his yield by 2%, the customer was able to generate an additional profit of more than 100,000 US dollars. Now, saving number 2 was the saving by virtue of reduction in total heat because of high ultimate vacuum. Because we were able to provide customer higher ultimate vacuum, thanks to the roots, the high efficiency roots machines that we were using, the customer got high ultimate vacuum, because of which earlier when he was running the plant at 370 degrees. We were able to reduce his effective heating from 370 degrees to 320 degrees. Now, in some cases, if you are already running at 320 degrees, you can expect delta to be coming down to 270 degrees. So, delta decreased by about 50 degrees only by virtue of providing higher ultimate vacuum. Earlier, the system was operating at 2 torr. We started operating the system at 0.05 torr, 50 microns. We were able to generate 50-degree reduced temperature at which distillation used to finish. We were able to save approximately 37.4 lakh rupees for the customer at going rate by reducing his diesel consumption into our process. So his diesel consumption went down thermic in the thermic boiler, and because of which he was able to save 37.4 lakh rupees, which is approximately 500,000 US dollars, 50,000 US dollars. The third saving that the customer had was the saving, and this was one of the biggest savings that the customer was getting. He reduced his batch time. Earlier, he was doing 22,000 liters in 10 hours. We were able to reduce this 22,000 liters, the same volume, we were able to process in 8 hours. Now that additional 2 hours that the customer got after every batch, saving in every batch, and the customer was running 600 batches in a year, he was able to save almost 1,200 new hours. These were 1,200 hours, additional production hours that were available to him at no additional fixed cost. Manpower remained the same. Investment in technology remained the same. He got 1,200 free hours in which he could take additional batches. Saving by virtue of this was 8.91 crores. The profit saving, direct profit saving that the customer saved. The customer shared his information with us that I save, or my processing cost per batch is about 30 rupees. This means if I buy used oil, I add 30 rupees to it, which is my processing cost, and then I sell that oil. 30 rupees is give or about $0.50. He was able to save almost 8.91 crores, which is about 1.15 million US dollars approximately. Small savings in power. He was able to save 6 kilowatt in this particular case. Pranshu, can you just have your pointer there? In maintenance, he was able to save about 4.2 lakhs, 420,000 Indian rupees. And apart from that, because we provide an intermediate condenser just before the liquid ring vacuum pump in our system, where we are able to condense. So it comes after the boosters. There is an intermediate condenser and then a filter trap unit. In that intermediate condenser, the customer was saving additionally about 40 liters per 8 hours, which also was otherwise either being mixed in water or getting lost into atmosphere. So this additional recovery also customer could reuse or sell, and it saved him about 12 lakh Indian rupees. When we consolidated this whole saving for the customer, we observed that originally customer was charging 30 rupees INR as processing cost per liter. Just by these savings, he was able to save additional 7.78 INR, which was 25.93% in this particular case. Additional saving for him that he could save based on the presumption that he was doing 22,000 liters multiplied by 600 batches. So additionally, he started saving 25.93% as his conversion cost, which was a big payback for him. And he realized that within 3 months, the machine's cost was totally recovered. After 3 months, whatever he was spending, whatever he was saving was direct benefit to him. The same analysis we have also translated as cost benefit analysis in US dollars as well. That slide is not a part of this presentation, but we would be glad to share it with each and every one of you if you reach out to us in terms of US dollar values. Now, coming to the next slide, which is the available models and their specifications. So these are the 5 different models that are available. For so the first says it for the is for the fixed loading, that is the batch process in kiloliters per batch, and the second column depicts the loading in for a continuous process, which is either a wide film or a falling film. In liters per hour, the feed rate that you can achieve, that we recommend or propose. Corresponding column of displacement is the volumetric displacement of the machine. Typically, in this particular case, because we've been discussing about skid 3, so I will take skid 3 only or oil cyst 3 only further. The typical displacement in such a case is of 12,500 meter cube. Now, this typical displacement of 12,500 meter cube is available at a working vacuum of 0.05. And the ultimate vacuum in such case for the customer is 0.01. Then we have the connected power. In this particular case, the connected power is 73 kilowatt. And then you have the consumed power, which is the actual power that is consumed by the system. Because motors are standard in sizes, we cannot always have a non-standard motor being designed for us specifically. So we use standard motors. But however, our actual power consumption is much lower as compared to that power range. A typical PNID, I'll be showing in the next slide. The process and instrumentation diagram. So as we told you, this whole system that is being offered is a complete skid mounted unit. It is a complete plug and play package designed to fit into a container and shipped to any part of the world. Comes along with a standard operating procedure and a manual that can be provided, and support that can be provided. The next slide shows a typical general assembly drawing, the GA drawing. I'll take a moment to highlight on the PNID the various components that are being used in this oil cyst. If we can just go back to the PNID. So the first two stages that are there are the two boosters. After the two boosters, there is a condenser. The flow from the condenser goes into the filter trap. That's on the side, yes. And from the filter trap, there are two liquid ring pumps at the bottom. These are both recirculation, 100% recirculation pumps, which come along with its own closed loop circuit for recirculation, along with a plate heat exchanger and a air liquid separator. The discharge line of the air liquid separator, we recommend, should be sent back into the incinerator or the boiler that is available with you, so that any saturated oil vapors that are there, we can harness the energy out of those as well. The next is a typical ISO general assembly drawing that is there. Now coming to the most interesting part of our presentation are some of the FAQs that we frequently keep getting. So this time we did something different. We have compiled all the questions that keep. Pranshu, you can go back to the last slide only. The FAQ, and maintain constant there. You don't need to come to this particular slide. Yeah, you can stay here. So these are basically most of the questions that we keep getting from our customers. We took the time to have the most appropriate answers ready for them, and we wanted to use them during this webinar today with all of you to ensure that we are able to answer most of the common questions that are asked. If still there are questions, you can post your questions in the question and answer, and at the end of the presentation, we'll take up all those questions. So the question that comes to us the most is, what will be the maximum process operating temperature of waste or used oil in the kettle? So typically, like I told you, typically under vacuum, if the correct vacuum level is maintained in the condenser and the kettle, and the whole vacuum system is packaged properly, the ideal operating temperature at the final cut should not be crossing 280 degrees Celsius, 250 to 280, worst case scenarios up to 320. If you are going higher than that, then either there is some problem in the design, and this will lead to unnecessary burning or a lot of residual carbon being generated into the system. Question number 2, what will be the yield when we use Everest oil cyst vacuum pump? So like I showed in a case study, which we did on a 6,600 liter batch process, our distillation, the yield that we achieved in the distillation was of 90% that we were able to extract out through the process of distillation itself. However, this being said, this is not always absolutely accurate because it does not only depend upon vacuum. You see, distillation mainly depends upon 4 different properties. Number 1, vacuum. It is very critical. Number 2 is the condenser. The condenser is equally as critical as probably the vacuum. And the number 3 is heating, which is also equally as critical as vacuum. So condenser, heating, and vacuum are the triangles which define what will be the equilibrium that will be set out automatically within the process. The 4th factor that in this particular case becomes important when we are talking about the yield is the source and the composition of feed. If your feed has too much of burnt carbon, too much of sludge already in the system, then yield can be lower. However, all of this being said, and presuming that all condenser, heater, and vacuum are sized in equilibrium, you can expect yield through distillation of up to 90% very easily. Typically, so in a typical installation, a yield of 90% is not too difficult to be expected. Question number 3, what will be the color of the output of the base oil by using your vacuum pumps? So usually the distillation process of used oil in distillation, the target that we have is to achieve stock 150, and color ranges anywhere between 2.5 to 3 as measured by a Lovibond apparatus. Question 4, what will be the operating vacuum level by using your vacuum pumps? As you are all aware, generally because distillation process is carried out under vacuum and oxidation plays a critical role in defining the output color, operating vacuum in final cut of distillation plays a critical role. Thus, at Everest, during distillation, we target to maintain a working vacuum anywhere between 0.5 to 0.05. And the ultimate vacuum of this system, when it is tested in our factory, is 0.01 millibar. Next question is, what is the viscosity of oil being circulated in the vacuum pump? Can we use treated base oil in the oil ring pump as a sealing fluid? Treated base oil, like I told you, our target for treated base oil is of SN 150, which has a viscosity of about less than 40 CST. That oil is ideal for use in this oil liquid ring pump, or this oil ring pump. The shaft, the mechanical seals, all have been modified accordingly to handle that oil. We do not recommend increasing viscosity of oil once the oil starts contaminating. There is carbon carryover that comes into the oil. It increases the viscosity. As the viscosity starts increasing, the power consumption starts increasing. So typically we recommend that around 40 CST is the ideal viscosity. If it starts increasing, going higher, say more than 50 or 60, we should replace or replenish this oil with fresh base oil. And here also, this oil does not get wasted. It goes back into distillation kettle, and fresh oil that is available in the distillation kettle comes out for further further running the pumps as a sealing fluid in the pump. The next question is, what is the advantage of using base oil in vacuum pump instead of water? So here I would like to answer with 2 points. Point number 1, every liquid ring vacuum pump is not suitable to run with base oil. Base oil has higher viscosity, has higher vapor pressure. Because it has higher viscosity, the power consumption is also slightly higher. For this, the shaft and the impeller needs to be strengthened. These pumps that are specifically designed for this application have already this design modification done into them. The other basic difference is standard liquid ring pumps. The water ring pumps use a different type of sealing, whereas this type of mechanism, because it is designed to operate at higher levels of vacuum, has mechanical seals installed in it. With this being said, the other advantage that you get once you are using used oil is because used oil has higher vapor pressure as compared to water. Ultimate, when you are using water as a sealing fluid, you are able to achieve a vacuum level of only 40 millibar. However, when you convert or change that sealing fluid to oil, the ultimate vacuum level of this liquid ring pump goes up to about 5 millibar, as opposed to 35 or 40 millibar that you were getting when you were using water. The other problem that happens when you are using water is that when it starts coming towards its ultimate vacuum, there is a very common process of cavitation that starts corroding the pump. However, when we do that same in oil, even though the pump is operating at 5 millibar, we are nowhere close to our ultimate vacuum. So a phenomenon of cavitation is totally ruled out. And because we are able to generate 5 millibar at the bottom on the base pump, the support that the boosters get at the top is very high, because of which they are able to generate much higher levels of vacuum. Question number 8. Why does it consume more power when used with oil as compared to water being used as a sealing fluid? So like I answered this question, oil has higher viscosity. Because oil has higher viscosity, it requires more churning power. And that is the only reason why higher churning power is required or used as when we compare it to water. Can this system be used in other applications? So question number 9. Can this system be used for other oil distillation applications or other distillation applications? So the answer here is yes. It is not necessary that you need to use this only in distillation of used or waste oil. Anywhere where you feel the sealing fluid is compatible with the process, whether be it an oil that can be used as a sealing fluid or be it ethylene glycol can be used as a sealing fluid. Question number 10. What is the effect of hot vapor entering into the vacuum system? What is the maximum temperature of the vapor that can enter into the vacuum system? So typically our recommendation is that when material is coming from the process, vapor is coming from the process, ideal vapor temperature should not be higher than 50 or 60 degrees. There is already very heavy compression that happens within the boosters, and this compression generates a lot of additional heat, which is called as heat of compression. So typically 50 to 60 degrees, if it is incoming, that is what should enter the boosters. There will be some amount of compression which will add additional heat to these vapors. But moving forward, before entering into the liquid ring pump, we have an intermediate condenser installed, which also acts as a heat exchanger, which reduces the temperature of the vapor and ensures that optimum temperature of vapor is achieved before it enters into the liquid ring vacuum pump. The next question that is there, what will be the bottom quantity after using the vacuum system? So like I already answered this question before, expecting 90% recovery through the way of distillation. I am again repeating, through the way of distillation means it has to follow that cycle. First evaporation has to happen and then condensation has to happen. Is reasonable, is logical. This means we presume about 1 to 2% are the losses that get carried forward in form of saturated vapor being moved out. Bottom, anywhere between 8 to 10% is reasonable, again depending upon the source of feed, how much contaminated the feed is. How is the vacuum system? How is this vacuum system better than the conventional vacuum system? So like I told you before, the current vacuum system is an optimized design which is based on our experience of more than 14 years and selling more than 8,500 machines. And this particular model, Oilsys only selling more than 200 machines, we have now continuously improved and matured up on our designs based on various feedbacks that we keep receiving from our customers continuously. I would like to point it out in categorize it in six different categories, the advantages that Everest has to offer. The first one being the pump uses oil as a sealing fluid, and that has a higher capability to generate more deeper and consistent working vacuum as compared to a conventional liquid ring or a water sealed liquid ring vacuum pump. So that's difference number one. Number two, there is high capability to handle uncondensed processed vapor and processed carbon carryover. There is some amount of hydrocarbon cracking that happens. Process carryover is carried into process, carbon is carried over. We have special filters that are designed to overcome this frequent choking, because of which our vacuum systems have very high capability to carry to handle processed carbon and uncondensed processed vapors. Number three, less prone to shocking as opposed to semi-dry running piston pumps. Because in piston pumps, there is compression happening, and in case there is liquid is incompressible, it starts damaging either the piston cylinder or the piston itself or the rings over a period of time. Whereas in this particular case, that is never a scenario that is experienced or observed. Number four, it is a very simplified design. Both the boosters as well as the liquid ring pumps are designed in such a way that they are very easy to service and maintain, be it anywhere in the world. This whole system comes with a very detailed operation and maintenance manual, which makes it a do-it-yourself kind of a scenario where you can maintain these systems very easily. Number five, the major differentiation that we have is because we are able to provide consistent deep vacuum, the throughput yield that we are able to promise to our customers is at least 2% better as compared to any other vacuum supplier that we have benchmarked ourselves with. The last one being minimum wastage of vapor which escape out of the system. Because the accessories that have been designed, the cyclone, the intermediate condenser, the filter unit, and then the air liquid separator ensure that minimal process vapor carryover passes out into the atmosphere from the system. Whatever passes out cannot be recovered is a direct loss of that batch. So our intention has always been to minimize that loss that is going out from the system. So these were the 6 advantages as how we score better as compared to conventional systems. Next, one more question that comes very common to us is, do we need a scrubber after or at the discharge of the vacuum system? We want to remove this smell. There is this foul smell that comes. So our answer for Everest Oil Cyst is no, you don't need a scrubber. The ALS that we have designed has been designed in such a way that it will control any particulate carryover that is going out or oil droplet carryover that is going out from the system. Only saturated oil vapors which are saturated in the air will be carried forward, and for that also we tell our customers that you should be sending these the discharge of this ALS into the boiler, recover energy from this saturated oil also, and only let hot dry air which is passed through the boiler exit into the atmosphere. So all the energy, if you see, we are trying to recover at various stages and ensuring that our losses in this case are minimalistic. Another question that we get very frequently is, why is an inline filter required at suction of the vacuum pump, and when does it choke and how do we clean it? So as you are all well aware, there is very heavy compression that happens within these vacuum pumps. From 1 millibar, we are going to 1000 millibar. So there is a compression of almost 1000 times that happens within the process. This causes polymerization of vapor. Now, when vapor starts polymerizing, it starts forming small carbon particles. These fine carbon particles pass through a filter that has been provided in circuit, and over a period of time, it starts building up within that filter and starts choking up that filter. As a resultant of which, customers start experiencing a pressure drop because of choking of that filter. Now, that filter that has been designed is a recyclable, reusable filter. It's very simple to detach. You just need to open the lid, remove the filter, wash it up either with a solvent or decarburizing agents, remove all the carbon particulate that has jammed into it, and reuse that filter. How many times you can reuse it? It depends on the method of cleaning. If the cleaning is not very aggressive, minimum 4 to 5 times that filter can be reused before you need to replace the cartridge. Another very common question that keeps coming to us is, how is consumed and connected power different? So connected power by definition is the standard motor power. Whatever are the standard motor powers, we add them up and we calculate and we say that this is the connected power, because this can be the maximum consumed power that the system will ever consume. Consumed power is the actual consumption that the machine requires for pumping. Now what happens? Initially, there is heavy evacuation that has to happen. The machine has to evacuate from atmosphere and come down to very high levels of vacuum. So there will be a lot of air that will be pumped out and sent out, which is the initial evacuation, which causes a lot of NCG to be removed from the system. However, later on, when we start operating, so this will only happen for the first 30, 35, 40 minutes into the process. When the system reaches its natural state of equilibrium of high vacuum, the power consumption reduces drastically because there is no NCG, non-condensable gas, that is left in the system. Because there is no non-condensable gas, you will typically observe the consumption of the boosters, motors, dropping by up to 70%. So originally, if a 10 kilowatt motor is installed in the booster, it was consuming, at initial evacuation, it was consuming 8 kilowatt. Towards ultimate high vacuum, after the first 2 hours, it will only be consuming 3 kilowatts. So up to 70% is the power saving, direct power saving that you can expect in terms of consumed power. And that makes the difference between the connected power and the consumed power and reduces the power consumption drastically for the system. One more very typical question that we get is that what is your delivery period? So delivery period for skid 1 is skid 1 to skid 2.5 is anywhere between 6 to 8 weeks. And skid 3 to skid 5, because these are huge systems having very high pumping capacities, is anywhere between 8 to 10 weeks. So these were some of the FAQs that we received, and I just wanted to have all of them compiled for all of you so that it gives you a lot of clarity and sense as to what are the typical objections that are raised and what are the typical, the most common answers to those, to bring more clarity to the subject. Coming down to the application areas. So now I am almost towards a last 2 or 3 slides that are left, maybe last 2. Like I told you, and then we'll come to question and answers. Here I would like to add, like I told you, we do not see any reason to refrain use of these systems only to used oil. Oil ring vacuum systems are very popular. We can just change the sealing fluid and we can use it for all these industries. In fact, we are already using it in a couple of other industries. These systems can also be very popular in edible oil. They can be very popular in biodiesel. They can be very popular in CNSL distillation. Most of the various applications that they can serve, we have vacuum distillation being the most common, but not the limiting one. You can have all these other applications also that can be served with this type of a vacuum system. The next slide is various industries that we are serving with these systems. So these are the various industries. Majorly, these systems are being used in petrochemical industries for distillation, vapor recovery, or drying applications. With this, I come to an end of my presentation. I am open to questions and suggestions. And I would like to thank you all for your time. So, Nishant?
Yeah. We have, good evening, gentlemen. So we are open for question and answer round. Pranshu, can you please go back to the slide? Yeah, okay. So we have question from Mr. Luis Meza from Mexico, looking out for if dry screw pump is better performance than LRP, why we do not use in this process? Mr. Dhruv, would you like to answer this question?
So yes, I totally agree. Dry screw is always a better choice. However, dry screw is slightly more expensive in terms of the initial capital cost. This being said, I would not like to limit that we do not use some customers. We have more than about 12 or 13 installations now where we have replaced, and these are installations all across. Some are in Africa, some are in South Africa, some are in Egypt, some are in Dubai. These are all customers who have installed dry screw as opposed to oil ring vacuum pumps. The advantage of dry screw is it gives you even faster, consistent vacuum. So your evacuation time further reduces. Maybe here we are doing that batch in 8 hours, there we'll be able to do it in 6.57 hours. The disadvantage being that in case the source of feed is not proper and you have very heavy carbon carryover, it will cause jamming in the choking or jamming in the dry screw vacuum pump. It will require more cleaning as compared to that is required in a oil seal. But if you are very sure and about your quality of feed and you're disciplined in that, dry screw is a great choice.
We have another question from a gentleman belonging to South Africa, seeking about how easy it is to install the machine themselves and what are the other major requirements in the plant to install the machine.
So there is a complete checklist, pre-checklist that we share with you of requirements. There is a requirement for foundation from your end. Machine needs to be on stable ground. It's a complete skid-mounted machine. There is a requirement of consistent electricity source, and apart from that, there is a requirement of cooling water in the intermediate condenser. Apart from this, there is no other requirement from the when it is in the process from the utility side. If I talk about installation, how easy it is to install, most of the customers that are abroad who are not in India generally or typically choose to install the machine themselves. There is a very detailed operation and maintenance manual that is provided along with the machine. And apart from this, there is a standard operating procedure that is provided along with the machine. In case required, our video service in such particular cases is being offered free of cost. However, if you require a physical person on site, then that is on nominal chargeable basis. We have more than 50 installations which the customers have done themselves. There is a very detailed video that is shared along with the machine at the time of testing of your machine itself. So you are very clear on the parameters as to how the machine needs to be installed and operated.
Thank you. Another question is from South America, from an existing user of our dry screw vacuum pump in this process, asking for additional benefits to be gained in operations besides the power that you have already explained, and about the maintenance cycle of the pumps.
So, like I explained, I will categorize our savings in 6 different categories. Power being a saving, but not a very big substantial saving. Now, this gentleman, if he was using a steam jet before this, then yes, power saving becomes substantially high. But in the cost benefit that I covered during my presentation today, I spoke about our comparison with a semi-dry liquid ring, a piston ring plus a roots combination machine only. There, the saving that they can expect from our machines are majorly in terms of yield, in terms of reduced temperature, reduced kettle temperature of final distillation, and in terms of reduced batch cycle time as compared to conventional. So these are three major savings. The secondary savings, I would say, is power, maintenance, and recovery of solvent. But the first three have a much higher dollar value as compared to the second three. So that's why I categorize them into two different heads. Yes. So yield, which was the second one, product yield, higher ultimate vacuum, reduced delta temperature, and reduced batch time are the main savings that our customers should be targeting or should be expecting by using this equipment.
Thank you, Mr. Dhruv. These all are the questions that we received today in our webinar.
Okay.
And even
Coming
if
to
still
the last slide, we would like to thank you all for being a part of this webinar today and giving us your precious time. How you can reach out to us, you have all our numbers available on your screen. Apart from this, there is this link, tinyurl.com/EverestVacuum-TSG. If you click on this link, or if you just click a photograph of this link and type this link, you'll be able to book a free 30-minute session with one of our vacuum experts who will answer to all your queries or help you in making the right selection of the product. Now, these are limited slots. We keep getting a lot of demand for these slots. So it's on, to be unbiased, it's on first come, first serve basis. I would urge all of you, please use this feature and book your 30-minute free slot with one of our vacuum experts.
Thank you everyone for your valuable time. Thank you, Mr. Dhruv.
Thank you, Nishan. Thank you, Priyanshu.